Now it's time for probably my favorite part of logic, and that's proofs. Proofs are often like a little puzzle, a game where you got puzzle pieces that you got to fit together. There's strategy that you got to use rules to try to get the conclusion. It can be a lot of fun. So I like it a lot. Not everyone will necessarily enjoy it, though I imagine some of you might really enjoy it a lot. So in this video, we're going to be starting proofs. We're going to be looking at implication rules. So first, we'll look at the parts of proofs. We'll then look at our 8 implication rules. We'll talk about what they are, how to use them, and we'll practice recognizing correct and incorrect use of those rules. Then we'll look at proofs that are already constructed for us, except the details, the annotations are left off. So we'll try to understand proofs better by applying annotations where we figure out which rules were applied where. That'll help you as we work our way up to constructing our own proofs, which is the most challenging part of proofs. So, and in that, I'll be going through proofs, walking you through how I construct them and my thought patterns and strategies as I'm going, including tips. There are tips in the book. Those will prove probably very useful to you as you're learning strategy and how to construct these proofs. All right, so let's jump into it. Let's look at what a completed proof looks like. This is a completed proof. In black are the things that you're going to be given, and then in blue is what you're going to do to complete the proof, to construct the proof. Up here we have our premises, lines 1 through 4, and then we have our conclusion. So this is an argument, and we're going to see if we can create a proof that will prove that the conclusion follows from these premises. And the idea is then below the line, this is what you're going to add when you're constructing a proof. You're going to add steps. There could be just one step or many steps, but you want to take steps, and eventually the last line you want to be your conclusion. So each line is going to come from your premises, 1, 2, 3 premises plus a rule, and you'll write how you got each step over to the right. Those are called annotations. So you always want to write your annotation of how you got each line, citing the number of the lines you used with the rule that was applied. And we'll go through how to do this in more detail in a moment, but I just want to show you this completed proof. So we can see that line 5 came from lines 1 and 2 using the rule HS, hypothetical syllogism. This line 6 came from these line numbers with that rule. And since the last line is the conclusion, this proof is complete. What are the rules that you can use when you're constructing a proof? Well, we're going to be learning a number of rules. First, we're going to be learning implication rules. Later, we'll learn equivalence rules, but don't worry about that for now. We're going to be learning eight implication rules. 5 of them up here on the board are already familiar to you because of our work in famous forms and logical operators and such. So we have modus ponens, or MP, and that should be painfully familiar to you, right? If P then S, P therefore S. The idea is above the line, if you have something in this form, then below the line or on any other line following in your proof, you can write S. We have modus tollens, which should be very familiar. Disjunctive syllogism. Here there are 2 versions, which it's just, you can negate either side, right? Over here we negate the P, the left side. Over here we negate the right side. If you negate one side, then you get just the regular other side as a conclusion. hypothetical syllogism, right? We can take two conditionals, if P then S, if S then R. We kind of cut out that middleman S, and now we just have if P then R. Constructive dilemma. This one, you'll know you can use it, especially when you see that disjunction, the V, and then you have two conditionals, and they go from, so we have P and S on each side of a disjunction, and then we have conditionals that go from each side to something new, and you can conclude that disjunction. Before we look at the other three new implication rules, let's first look at how to use these rules. The idea here is you can replace each of these lowercase italic letters with any statement, as long as you do it uniformly, and that can net you an inference. So if we replace P with F, right, everywhere P occurs in the rule, we replace it with this statement letter, F, and then everywhere that G occurs, everywhere that S occurs, we replace that with G. We do that uniformly. Well, then what are we going to get as an inference from these two lines? We're going to get G, just as from if P then S, P, therefore S. Now instead, since we replace the S with a G, we get a G. And of course, you can replace these lowercase letters with a simple atomic statement, but you can also replace them with more complex statements. In this example, now we have not F. If not F, then not G. Well, instead of just replacing P with F, we could actually replace it with not F. So everywhere P occurs, we replace it with not F. And then everywhere S occurs, let's replace it with not G. Whoops. So if we replace it with not G, then of course now our result is not G. But you can get even more complex. If you see these two lines, you can still use modus ponens. Now we'll replace P with this whole complicated statement right there. And so L or R, and then this P will replace with the same thing, and then we replace S now with not M, right? And so that is a correct use of modus ponens. It can get very complex. When you're using the rules and substituting in statements for the letters in the rules, precision is important. So look at modus tollens here. We have two examples. On the left, let's see, we replaced P with H. So that's simple enough. But notice here, we have not P. And if we replace P with H, right, we're going to leave that not out there. So the result is not H. What about with the C? Notice we got double negations going on here. What's up with that? Well, we replaced S with not just C, but not C. So you can include that not in there, but you got to be uniform. Everywhere you replace it, you got to replace it with the same thing. So we replace the S here with not C again. You always replace it with the same thing, right? But then notice this negation out here. Now it becomes two negations. So then we get not C. And so this matches the modus tollens rule. You might be tempted, because intuitively it makes sense, if you see this construction, you might be tempted to write modus tollens and do not H as an inference, but that is not precisely correct, because if you replace S with not C, well, you're not replacing it with the same thing here, right? You actually even dropped part of the apparatus in the rule. So while intuitively correct, you're going to need to avoid that common temptation. Later, we'll learn other rules that Well, I'll show you how to convert this. We'll just have a rule that adds two negations, and surprisingly enough, it'll be called double negation, but that'll come a little later. Right now, we're just going to focus on the implication rules. Double negation is an equivalence rule we'll get to a little bit later. Another new rule. So we've seen the 5 of our new rules already that are familiar. Here we have one called simplification, or you can just abbreviate it. So simplification takes a conjunction and just breaks it up. So here we have P and S, and if you have that, well, you can just write P, because a conjunction, that's just saying two things. It's like this and that. Well, if this and that are true, then this is true, right? So you can take, and so we have two versions because you can take either side, doesn't matter. So here's an example where we plugged in G for P, and here we have E for S, right? So you can get that. However, notice this is different. Instead of an and, so this is conjunction, and if you see a V, that's or, that does not work. You cannot simplify a disjunction. That doesn't work because it's or. It's, you can, so either the Bears will win or pizza will be free. Well, from that, you can't conclude that the Bears will win, right? Because you just pulled that out of an either or. You don't know for sure that the left side is true. So you can't simplify a disjunction. You can get more complex here. Instead of something simple, we replace P with this whole long thing, right? So you have something complex, you can pull that out, just as long as you replace P with the same thing every time. Our next implication rule is conjunction. Conjunction is very similar. Well, it's kind of the other side to simplification. Simplification, we broke apart a conjunction. Here, we're making a conjunction. So if you have two lines in your argument, in your proof, you can just put them together with conjunction dot. Even if you have complex lines like this, you can just put them together with a dot. Of course, making sure to add parentheses in there to avoid ambiguity. Finally, we have our last rule, addition. This implication rule is rather strange. If you have any statement, you can simply add the or and then add any statement after it. So say we have, but you don't have to add it after, you could also add it before, so that we do have two versions, right? So here we added S to the right side. You can just add something, the S to the left of the P, that's fine too. So here we have this as a statement, L, if L then B. Well, from this line in a proof, we can write a new line and just add or and write anything we want over there. These letters may not have even occurred in our proof at all. They're brand new. We just pull them out of thin air. That's totally fine. That seems kind of strange to a lot of people, right? Well, think about it like this. Remember that our or is either or inclusive, and if just one side of an either or is true, that makes the whole either or true. So if we have this line, Baylor is in Texas, and that's true, well, from that, we could infer that this either or is true. Either Baylor is in Texas or Disney went bankrupt. Now, we know Disney didn't go bankrupt. It's probably not going to go bankrupt anytime soon, but we know this whole either or is true because one side of it is true. So the truth value doesn't change, and that's why you can write anything you want when you add it to a true statement with an either or. So addition is a nice rule, and it'll come in it'll come in handy a lot of times. Anytime you need to prove something and you see a statement letter that you need to get, but it doesn't already occur anywhere in any of your premises or anything, you're probably going to use addition. Now let's see if you can recognize which, if any, rules are being used in an inference. Maybe a rule's used, maybe it's not. If it is, which one? So what about this one? Do you think any rule is being used? What do you think? The answer is yes. It's hypothetical syllogism. So we replace not W, that's replacing P, and then S is being replaced by this whole longer complex statement. And then, of course, R is replaced by A. So yes, hypothetical syllogism. What about this one? Is this the right use of a rule? The answer is yes. This is disjunctive syllogism. We've replaced the S with this long thing. And be careful of the negation sign. So we replaced the S, but we left that negation there. So we still have it here, but there's no negation up top. What about this one? Is this the use of a rule correctly? What do you think? Yes, constructive dilemma, right? We have our disjunction here, either or, and then we have conditionals going from each side. So from this side right here and from this side right here, and we go to something new and get a new disjunction. What about this one? Is this the use of a rule? Yes, this is addition. We just added that part over here, right? We know this, assume this is true. Well, we can say, well, either this or this new thing, Z. Before we start constructing our own proofs, it's a good idea, I think, let's practice annotating a proof. So this proof has everything except the annotations. Normally, the black part would be what you're given, the premises and a conclusion, and then you're supposed to construct the steps and end with the conclusion at the end. The idea, of course, each step is following a valid rule, so that means the conclusion follows validly from the premises. So, but this one, we already have it filled in. We just have to figure out how they got each line. So how do you think they got line 4? Not S. Is there a way that we could get not S from our premises? Well, where do we see not S? We see it in line 2. So we could probably get it from line 2 plus something. Well, if you think through your different rules, hopefully you think of modus ponens. So 2 and 3 together, using the rule modus ponens, that works real nicely. In with if in then not S, well, that'll give us not S. So that's what we would write for annotation for line 4. What else? Line 5, how did they get not W from what they have so far? Well, for a new line, you can use not just your premises, but you can also use the new lines that you write, right? So for a line, the previous lines that you can use are anything that comes before, except of course the conclusion. You can't use the conclusion when you're trying to prove the conclusion, right? That would be bad, it wouldn't work. So not W, well, in line 1, we have if W, then S, and in 4, we have not S, so hopefully you thought of modus tollens. So modus tollens with lines 1 and 4 is going to give us exactly what we needed, not W. So that's how you annotate that one. Now let's annotate this one. So in black, we have everything you're given, the premises, conclusion, and we already have it completed for us, the steps that you would normally construct yourself. So we just got to write how they got each line. So W and C, number 5, how do you think they got that? So W and C. Well, where do you see that occur? Well, it occurs here in 2. So maybe they got it from 2. Could they have got it from 2? I don't really see how, because, maybe modus tollens, but that wouldn't really work. What about line 1 and 3? Maybe they get, so we have W and we have C, and this is just W and C. So looks like they could get 5 from conjunction, 1 and 3. So 1 and 3 conjunction gives it to us. And how did they get 6, M and V? Well, I see M and V up here. So it looks like maybe they got it from 2. Yeah, if you look at 2 and 5, right? So W and C, we could just do 2 and 5 modus ponens, and that's going to give us the M and V. So 2 and 5 modus ponens. What about, what are we on? 7. So V all by itself. That's pretty simple. We just take 6 and simplify it. Break that down, right? You can just take part of a conjunction. So now we got V, and we just got to get F. Well, we get 4. 4 plus 7 modus ponens. 4 and 7 modus ponens. That's going to give us the F. Awesome. So that's that one. Let me now point out a couple important things about using implication rules in proofs. The first is that these implication rules, they apply only to an entire line of a proof. You can't just apply them to part of a line. So for example, if we have this line in a proof, can we apply the rule simplification and get this line? No, we cannot, right? This is T and F. If this was all by itself in a line, yes, we could pull out T, but because this is just T and F is part of this longer line, we cannot apply simplification to just part of the line. So this is incorrect. You cannot apply implication rules to parts of a line. Later, we'll have something called equivalence rules where things are different, but for now, these eight rules, implication rules, you cannot apply to part of a line. So why? Well, here's an example. If T and F stands for trips and falls, right? So if he trips and falls, then people will laugh. Well, from that can you conclude if he trips, people will laugh? Well, maybe, but it doesn't follow, right? Because this is saying you need both. If he trips and falls, then people will laugh. So just tripping is not enough. So this is not a valid inference. This line doesn't guarantee that this line is true. The second important thing you want to be aware of is that you only want to make one application of one rule per line. Take a look at this. We have two premises, a conclusion. Looks like, so they got not be the conclusion. How'd they get it? Well, they say 1 and 2 modus ponens, but for modus ponens with 1, we need A by itself. Now A's in this conjunction, and of course, if it's in a conjunction, you could just simplify. And they kind of just did it all in one step, but this is not correct. You actually need to take 2 steps. So this is incorrect. First, you need to simplify line 2, and you'll get A, and then you can do modus ponens with line 3 and line 1. So don't try to do multiple applications of rules in one line. That can hinder things in terms of learning, even though it might save you space, or you're doing things in your head. Instead, it'll help you if you write out each application of each rule and just one on a line. And now we're ready to construct our own proofs. Let's do this one. This is from page 360, number 3. When constructing proofs, there are 5 tips the book gives you, and these will be very helpful whenever you get stuck to go and check these, try to see if those tips help you. The first one is super important, and it's always, always, always check to make sure you copied down the argument correctly. I can't tell you how many times this has saved me, but also how many times I haven't checked and then spent like an hour on one problem and I can't figure out the proof. Then lo and behold, I go and look in the book again, and it's because I copied it down wrong. And the way I copied it down, it's not possible to even prove it. So it'll save you a lot of time. Just check, make sure you copied it down correctly. You don't want to waste your time. So let's go ahead and see if we can do this proof. Well, we need to get not R somewhere down here, and we have 3 premises to work with. Another one of your tips is look for the conclusion or parts of it in your premises. I believe that's tip 3. And do you see it? So not R, well, we see it right here. And is there any way we could get not R? Well, if we got the denial of E, so not E, then we could do disjunctive syllogism, right? And that would give us not R, so that would be nice. Another one of your tips for proofs is see if you can notice any patterns of rules that will be helpful. So do you notice any? I notice 1 and 2. Take a look at that. This 2 is the denial of the consequent in 1. So that makes it perfect for a modus tollens. So let's do that. So we'll go ahead and enter our first line in our proof, and we're going to take 1 and 2 and use modus tollens, and the result is going to be not E. Right? The denial of the stuff in parentheses, that's the denial of the consequent there, so that gives us not E, modus tollens. So now we have something new to work with, not E. We need to get not R. Well, lo and behold, look at 3 and 4. 3 and 4 together, we can use disjunctive syllogism, and that'll give us not R. Deny one side of an either or, and that gives you the other. So awesome. That is it. We got our conclusion going step by step using our rules, and that shows that this argument is valid. Now let's try this example. This one already right away. What do you see? Well, 1 and 2, hopefully you recognize that's great for modus ponens, right? So this is what we're trying to get. Well, we can get the not P. So 1 and 2 modus ponens gives us not P. But what are we going to do now? We got to get K, and we don't have K anywhere. Well, one of your tips, I guess number 5, if you need to get something, a statement letter, and it doesn't occur anywhere in your premises or anywhere above, what you need to do is almost always addition at some point. So why? Because addition lets you just add something in there, right? Totally new. So we can just take line 3, we can just add the K or part, and that gives us K or not P. So that's just 3 addition, right? That's a nice little trick you can do. So remember, because if not P is true, it really doesn't matter what we add, because this disjunction just needs one side to be true to make the whole thing true. So there you go. Let's try one more example. So this is page 362, number 20. Here we got three premises. We're trying to get this disjunction as our conclusion. What are we going to do? Well, what do you see? Do you see your conclusion in your premises anywhere? Well, we got not B. Here we got B's in two different premises. We got E. What can we do? Well, that's not too helpful. What about, is there any pattern that you see or any rules that you can apply pretty straightforwardly? I don't see what we can do with like 1 and 2 together. What about 3? Is there anything? Well, maybe with 1, yeah, look at that. This is a double negation, right? So the negation of C. So that's like the negation of this side of this disjunction up there. So we could do 1 and 3 disjunctive syllogism. And that's going to give us B, right? This is the negation of the right side of that either or, right? The negation of the right side. So that means the other side is what we're going to get. So we get B. Well, that's great. Well, are we any closer to getting our conclusion? We got not B over here in the conclusion. We just got B. Well, now this opens up 2, right? With 2 and 4, we can do modus ponens. So just think what you can do with your rules. Do they fit anywhere? That's going to help, because if we get E, well, that's part of our disjunction. So from that, we get E. Well, now we just need not B or E. Well, remember the last example, we can just add anything to something we already have. So you might try to work with what you got and somehow get the not B part of that either or, but don't forget about your add rule. So the tips there can be helpful. So we'll just take 5 and add the not B part. So not B or E. There we go. That one was a little tricky. You might have got caught with, you get B, but somehow you got to get not B, and you got to get these together, not B or E. Well, the trick here is really using that addition. That's it for this video. Thanks for watching. Look out for another video soon, because I'll be posting video or maybe little individual videos where I practice doing proofs and talk through my thinking and strategy as I do them. Getting a lot of experience constructing proofs is really important to getting good at them and being able to do them. So look out for that. Also, hopefully the homework and the quiz, as well as the AAA, they should all be posted very, very soon. Maybe by the time you see this video. Thanks for watching, and I'll see you in the next one.